Alright, so naming hydrates sort of combines together ionic name and covalent naming. There are components for both of those when you're dealing with hydrates. Now, I already went over what a hydrate is. It's just basically a compound that contains water molecules within its crystal structure. They are ionic compounds, but they do have that covalent part of them as well, which is the water. Now, when you name hydrates, I recommend taking it into two parts. First looking at the first part, which is your ionic compound, or the ionic part of it, which you would name just like a regular ionic compound. You would split it in half. You would find the charge of the second half, so SO4 has a -2 charge. Now, because of the fact that SO4 is a polyatomic ion, you have to see whether or not it's in a parentheses. In this case, it's not, so you can't multiply those two together. That together, you have to leave it as -2. So that means Mg has a +2, and then you would just name it from the periodic table. So Mg, if you look on the periodic table, it's in group 2, so you can just name it as magnesium. And then SO4, if you look back, at that chart that I gave you, it's just basically sulfate. So that takes care of the first half of your hydrate. Now, the second half, if you notice, you have a coefficient, and then you also have water as well. The water part is always known as hydrate, no matter what. So you'll just put hydrate at the end of this name. Now, you do have to take into consideration, though, the 7, which, to do that, you just deal with the prefixes that you learned when dealing with covalent compounds. So 7, if you remember, is hepta. So in this case, you'd have magnesium sulfate heptahydrate, and that would be the name for this particular compound. Alright, next example, same thing as before. This part is ionic. Split it. Figure out the charge on this half, which is the same thing as before, SO4, which is -2. Can't multiply those because the polyatomic SO4 is not in parentheses. So that means Cu is the +2. If you look at the periodic table, you'll notice that Cu is a transition metal. So you would put the name, which is copper, and then you also have to make sure you put in the Roman numeral, which is 2, which goes along again with the charge. SO4, like we did before, is sulfate. So that takes care of the first half. Now we deal with the second half, which again, you deal with prefixes for that coefficient. So 5 is just basically penta. And then the water, like I said, would be hydrate. So in this case, you'd have pentahydrate. So the whole name for this would be copper 2 sulfate pentahydrate. Now let's just go in the opposite way, which you have calcium sulfate. So if you look calcium up on the periodic table, you notice that it has a Ca for its symbol. If you look at the charge, or if you figure out the charge, you'll notice that it's in group 2, so it has 2 electrons. So that means it's going to lose 2 electrons and make a +2 charge. Sulfate, we've been dealing with this for the past 2 problems, is just SO4 -2. Like I said before in a previous video, the 2 charges are equal. You have a +2, you have a -2, so that means you can just put them together. So you have CaSO4. Now to take care of the dihydrate, di is just basically 2, hydrate is just water. And because it's a hydrate, make sure you put the little dot in the middle because that represents hydrate. Alright, and for the last example, look at sodium. Sodium is on the periodic table, and it's just basically Na, and the charge is a +1. Thiosulfate is a polyatomic, so it's one of those that you need to memorize. It's S2O3 -2. In this case, the charges aren't equal, so you need to do the crisscross rule with them. Making sure to get rid of the charge itself, you just bring down the number. So you have Na2 S2O3, and that would take care of that first half. Second half, you have pentahydrate. Penta is just basically 5, hydrate is H2O, and then just make sure you put the dot in to represent hydrate.